So these two have to happen. Terms without age must cancel out, and age from the denominator must go away. Notice that there is an age still left in the expression, which is okay, but it's not this one from the denominator. This is the second step. In the second step, this age must go away. There is still an age left in there. That's okay, but it's not this one. This one was simplified. Any questions before we look at another function and determine the difference quotient? Any questions on the difference quotient for a quadratic function? Do you need me to go back to anything, or can we move on? Is this okay? Okay, so I'd like us to choose a rational function now and determine the difference quotient and then move on. Can anyone give us a rational function? It's okay if you don't remember, and I'll explain. Can anyone give us a rational function?
Like 2x plus 3 or something. F of x is 2x plus 3.
If it's called a rational function, it has to have a ratio. If it doesn't have a ratio, it's not a rational function. And it has to have x in the denominator. Two x over 3 is not a rational function. Why? It doesn't have x in the denominator. This is linear. So let's try again. An example, a simple example of a rational function.
Three over 2x.
Good. 3 over 2x plus 1. I'm going to make it a little bit slightly more involved. Okay, so this is the function. The question is the same. Find the difference quotient and simplify it for something like this. So the difference quotient, by definition, f of x plus h minus f of x divided by h. I don't need a lot of work on the side for this function. I can write minus f of x, which is 3 plus x over 2x plus 1. I can write h in the denominator. Now, can anyone come up with an f of x plus h for this function? And I will write it down. Please give it a shot. It's okay if you're wrong. So
would you substitute in
yes.
x plus h, so it would be
exactly
3 plus x plus h.
Excellent. Very good. Awesome. Over
2 times x plus h plus
when
1.
You say this, right?
Yeah.
Perfect. Awesome. Excellent. That's it. That's all I needed. Good. I'm going to distribute here. So I have 3 plus x plus h over 2x plus 2h plus 1 minus 3 plus x over 2x plus 1 divided by h. I want to say that this particular expression, I do not consider it trivial. It's not a trivial situation. So we have to talk about it slowly. So I'm going to come back to this. I just want to discuss something called least common denominator, LCD, the least common denominator. If I have 1/2 plus 1/4, 2 is a factor of 4, so the least common denominator is 4. 2 times 2 is 4, so I need to multiply the numerator by 2. There is no change here, so 2 plus 1, so I get 3/4. If I have 1/2 plus 1/3, as an example, these two have nothing in common. The least common denominator must be the product of the two. And I ask myself, 2 times what is 6? Okay, times 3. 3 times what is 6? Okay, times 2. So I have 3 plus 2 at the top. So I get 5/6. So these are numerical situations. Of course, easier than this. But the idea is the same. The steps are the same. So if one is a multiple of the other, easy. I just multiply by something that I call these adjustments, right? If I multiply the denominator by 2, I have to multiply the numerator by 2. Otherwise, I change the value of the fraction. If the two have nothing in common, here, this was a multiple of 2. But here they have nothing in common, so the least common denominator is 6. Again, I have to make the necessary adjustments to get the final answer. Okay, stay with me. So I'm back here. I have to add or subtract these two fractions. I have to find the least common denominator in the numerator. So after that, I have to find something called adjustments, right? As we did here. They had nothing in common. I got the product of the two. I needed an adjustment on this fraction to change this one into 3/6. I needed to change this fraction into 2/6. So 3/6 plus 2/6 was 5/6. In the same way here, I have to find the least common denominator. What is the least common denominator of 2x plus 2h plus 1 and 2x plus 1? I have to write it here and then the necessary adjustments. Here's a hint. It's exactly the same procedure as here. These two have nothing in common. They do not have common factors. So therefore, what will be the least common denominator here of these two?
Would you pull out 2x plus 1 from both sides?
These are not factors.
Okay, understood.
Meaning, there is no common factor here of these two terms. So this is it. Carved in stone, fully factored. There is nothing here that I can pull out. These three terms do not have a common factor. Carved in stone, fixed. Very good question.
Would you have to multiply them because they don't have anything in common? So would
Absolutely.
that be
Absolutely the same procedure. Thank you, Haley. Exactly
Yeah.
the same procedure. Thank you. So it doesn't matter which one you put first because this is the same with this. I like to put the first one as being the one with two terms and the second one, it doesn't matter. You can write them in any order you want. A times B is B times A. So 2x plus 1, 2x plus 2h plus 1. They have nothing in common. This is fully factored, this is fully factored. So it must be the product of the two. Now, what do I need to multiply this fraction by? Well, what it does not have in the denominator. Which one of these two factors it does not have in the denominator? That's what I need to multiply by. Which one? This was multiplied by what?
2x plus 1.
That's it. I needed 2x plus 1. And of course, this was multiplied by what?
Two x plus 2h plus 1.
Exactly the other one. Exactly. 2x plus 2h plus 1. Okay. I know I'm not going to have enough room here. So I'm going to go to the next page. Forgive me for that. So I'm going to put a triangle this time. From here and also from here, the same thing. Please follow the triangle so that I can continue here and finish it. Okay, here's my triangle. When we multiply this quantity by this quantity, we have to do this. 2x distributed to these three terms, because we have to put them side by side and we have to FOIL. But it's not FOIL because this has 2 terms and this has 3 terms. So instead of writing them here and writing pages and pages of work, I recommend 2x times 3 2x times 3, 6x. 2x times x, 2x squared. 2x times h, 2xh. So I distributed 2x to these 3 terms. Now I have to distribute 1 to these 3 terms. So that's easy. Plus 3 plus x plus h. I completed this product. This product is completed. Now I'm here with minus. But I have to multiply now this binomial by this trinomial. Luckily, all terms are positive, but I have minus in front. So everything I write will have minus in front. 3 times 2x with minus in front. 3 times 2h with minus in front. 3 times 1 with minus in front. h times 2x with minus in front. X times 2x with minus in front. And x times 1 with minus in front. All remaining terms will be negative. So, negative 6x, negative 6h, negative 3. Minus 2x squared, minus 2xh, and minus x. Sorry about that. I still ran out of room. So this is minus here. So 6x plus 2x squared plus 2xh plus 3 plus x plus h minus 6x minus 6h minus 3 minus 2x squared minus 2xh and finally minus x. Of course over h, but h is the same with h over 1. So I have a fraction at the top and a fraction at the denominator. What has to happen next? Mandatory and forever when we determine the difference quotient for any function. What is the first step that has to happen after all this is done, after the algebra is done? Anyone remembers what has to happen for sure?
What terms
Is it
were
a-
not used was canceled?
Excellent. All terms without h at the top must go away. Let's see if I can open. Okay, I was able to open it. Okay, 6x gone. 2x squared positive with negative, gone. Positive 3 with negative 3, gone. Positive x with negative x, gone. Luckily, okay, positive 2xh with negative 2xh, wonderful. Let's see what is left. This is left, this is left, and there is nothing else. So now let's combine like terms at the top. Positive age with minus 6 age. What is that? Positive
minus 5h.
minus 5h. Do not forget the denominator. The denominator does not go away. So we have 2x plus 1, 2x plus 2h plus 1. Now I hope you remember, when we divide two fractions, we copy the fraction from the top and we flip and change it into a product. So h over 1 becomes 1 over h. What is the second step that has to happen forever and always when we determine the difference quotient for a function and simplify it? What is the second step, mandatory step?
The h in the denominator must simplify with the h from the numerator.
Exactly right. And this is it. Negative 5 over 2x plus 1, 2x plus 2h plus 1. What is this? That rate of change, the average rate of change of the function between 2 points that are extremely close to each other, called the difference quotient. Why do we need it? For chapter 1 and moving forward. That's why we need this for. Okay. Now, one other topic I want to go over before we start R.1. Any questions on this? This was a marathon. Yes, I write big. Yes, I write with a marker so you can see what I write, but still a lot of steps. First of all, I had to come up with f of x plus h. Then I had to find the least common denominator. Then I had to find the adjustments. Then I had to multiply so that I don't, the reason why I don't write them side by side, because I don't want my students to be tempted to simplify 2x plus 1 with something and this with something. No, that's the reason why I don't write them side by side. So I wrote all the expression, and then I had to think, okay, what has to happen next? Okay, all terms without age must go away, and if some terms with age go away, it's even better. But definitely the terms without age must go away. Why? Because I have to have this age that finally removes the denominator. That's the reason why those terms have to go away. Otherwise, I will not be able to factor out an age that will eliminate this. And then I had to write the final answer, and I have to say this. So a lot of steps, a lot of algebra, not a trivial issue or a trivial problem, not at all. So rational functions are way more sophisticated than quadratic functions. As you see how many steps we needed. Okay, good. So the other thing that I want to present before we start chapter R, which is a review, is a very important concept. It's from algebra. It's very easy, but some students have difficulties with it, and I would like us to make sure that there are no difficulties here. Something called piecewise defined functions. I don't want anyone to be afraid of this function. It's really very simple. It only has basic algebra in it. Okay, so what I would like us to do is graph a piecewise defined function. Okay, so because I wanted you to see, so page 23. I'm gonna share my screen, assuming I'm not logged out of Pearson, because they do that to me all the time. Okay, I want to go to page 23. So we can choose a problem. You can choose a problem. So, okay, so what did I do? Okay, so this is how a piecewise defined function looks like. This has 3 branches, 3 branches, 3 branches, 2 branches, 2 branches. We can make one up on our own, or I can make one up, or we can choose one from here. So allow me to make one up, and then we can choose one if you'd like. I'll make one, a very simple one. So let's say f of x equals 2x minus 4 for x less than or equal to 2, and x plus 1 for x greater than 2. I created a piecewise defined function with 2 branches. You can say, where do I need this? Would give us an example in real life. Yes, it's coming up soon. It's due for us individuals on April 15th, and it's called the tax code. I know very little about the tax code, but it's a piecewise defined function. Meaning, if a person makes making stuff up as numbers, from $0 to $50,000 per year, the tax code has a function, let's say 2x plus 4. For somebody who makes between 5,001 and 100,000, the tax code is 2x minus 3, making stuff up, and so on and so forth. That's a piecewise defined function, meaning for every piece of x, there is a different function. For another piece of x, a different function. For a different, I don't want to say range, because range is, but that's what it is. A range between two different values of income, a different function. And that's the tax code. Unless we go to something much simpler, that's what it is, what it is. Okay. So that's an example. Now, every time I'm asked to graph a function in general, the first thought I have is the domain. Because I need to identify where the function exists. For example, if I have f of x equals the square root of x, I don't know if you remember, but the square root of x requires x to be positive or 0. Because the square root of negative 4 is 2i. It's not a real number. So every function has a domain or different restrictions, who knows? So I need to know what I'm looking at. So when I look at this function, I see 2 intervals here. Well, the first interval, I hope you remember, it's negative infinity to 2 with a bracket. Do you remember that? Less than or equal to 2, to the left of 2, from negative infinity to 2. Do you agree with this? What about the second one? Can anyone give us the second one in interval notation? This is the interval notation.
In parentheses, 2 to infinity, positive infinity.
Very good.
Another parentheses.
Excellent. From this point,